Welcome to the GMS MODFLOW Managing Transient Data tutorial. There's more information in the printed version of this tutorial. This video is to help you through the process of completing the tutorial. To get started, make sure we have a clean GMS, and we're going to open up the tutorial files associated with the Managing Transient Data tutorial. So click Open, and we're going to select the start.gpr file. When it opens, you should see we've got some contours, a few rivers in there, a head up top, nice grid with some wells, and a conceptual model, and our MODFLOW simulation. So we're going to start and select File, Save As. Save this as Trans 1. I'm going to do this so we've got a different project file save for every run through we make, and then you can save periodically as we go through the tutorial. So as we start, we're going to work on the recharge rate. So we've got several different zones for the recharge. So make sure the recharge coverage is selected, and select the Select Polygons tool, and then select the big middle one and the big middle polygon, double click it, and we're going to change the recharge rate to Transient. Then select the little button just above that, and we're going to enter in the recharge rates. It's good practice to enter in the recharge rates in Excel or as a text file. If you haven't, though, you would enter them in right here. We, however, have made text files to do this. So for Zone 2, we're going to select Import and click Zone 2 XYS. And then Zone 3 are these two side ones. Hold Shift, right click, and go to Attribute Table. Change it to Transient Import. Zone 3. And then this bottom one, double click, change it to Transient, and import Zone 4. Now that we have our recharge zones all set, we need to make sure we have the correct pumping data. So go to the Sources and Sinks coverage, and then select the Open button. We're going to open the pumping.txt. So under File Type, go to All Files, and select this pumping. You can even go to Text Files right here, and we've got pumping. So open that, brings up the text import wizard. Switch on heading row and click Next, and then change GMS data type in the top left to pumping data, and click Finish, and select Yes at the prompt. And you can double click on any of the wells. We got 3 of these. Double click on any of those. So make sure you get the right tool, and make sure it says Transient. You can even check the flow rates if you wish. Now to assign a specific yield, double click the hydraulic conductivity coverage, and under aerial properties, scroll down to get specific yield, then click OK. Grab your select polygons tool again, and then select the middle two polygons, holding shift, right click, and select attribute table. Enter a specific yield of 0.2 for both polygons. And then for the other 3 polygons, enter a specific yield of 0.15. So before we take this conceptual model and convert it so we have it in our 3D grid, we need to set up the stress periods. So we'll go up here to MODFLOW, and let's see, we're going to go to global options. We're going to change the model type to Transient. Then click the stress periods button. Make sure the use dates times toggle is on. It's important. Makes it really easy to input the stress periods. And then change the number of stress periods to 7. Now enter the data for times and time steps for all the stress periods. Okay, this is what your stress period should look like. Number of time steps automatically calculates the length. And keep the first one at steady state so we have a good starting point for the rest of our simulation. And click OK to get out of both dialogues. Right click the big valve conceptual model. Okay, and select map 2. It's kind of hard to see here. See if I can get this. There we go. Right click the big valve model, select map 2, mod path MODFLOW, and then select all applicable coverages. Select OK. And now we are mapped on. So in the Project Explorer, expand the global package and select the starting heads dataset. So everything's expanded, so we'll select the starting heads dataset and double click it. Now we're going to do 3D dataset to grid. Expand, expand, and select head. And click OK twice. We'll go ahead and save it. So we're ready to launch MODFLOW. So we just saved it and click the Run MODFLOW button. Once GMS is finished, make sure it reads solution and click Close. We'll read it in the solution, and if we select the head data set, it gives us our different time steps. And if you click the top one and scroll through, you can see how the contours are shifting. Next, we're going to select the Open button and change to Project Files. We're going to open up the wells. Only click once, and then select this bottom part that says Import to Current Project. And open. Now we should have several observation points appear. Okay, those will be more apparent when we run MODFLOW again with their observation targets. So we should have an observations wells conceptual model. If we scroll down, we do. We'll expand that. Click on the observation wells coverage and double click it. Then in the observation points over here on the far right, select Transient Head. Then click OK. Now select Open and change file type to text. And we're going to grab the transobs text file. Make sure the heading row is on again and select Next. Change the GMS data type to Transient Observation Data. And over here in the Trans Head column, we're going to change this to Transient Head. So click Finish. So now we're going to rerun MODFLOW. We're going to rerun MODFLOW, and when it asks to save, select Yes. And now we've got new contours, and our observation targets show us how close we are. Now we can view the error associated with the whole model, and to do this we're going to right click the Trans 1 solution and select Properties. This dialog shows a list of the error norms associated with the model. And next we're going to show a plot with the calibration targets and the observed values. So click the Plot Wizard button, then select Time Series for the plot type. Select Next, and I'm going to select points 8 and 10. And then turn on the calibration targets and the observed values, and I'm going to click Finish. I'll expand this so we can see it better. So this shows our time series plot. We've got 8 and 10, points 8 and 10 on here. They're at different values, but each of these are the calibration targets at the different times of the year. And we've got our calculated head. We can see how those match up with our targets. If it's within the target range, our air is right there along with the target. You are welcome to continue to look at the time series plot with different points and the conceptual model and our time step window over here on the left. This concludes the GMS MODFLOW Managing Transient Data tutorial. Thanks for watching.